Hello everyone, this is Jian Rahman from the Department of Chemical Engineering of Bangladesh University of Engineering and Technology. Today we are going to solve some problems related to material balance, and the problems are taken from the fourth edition of Elementary Principles of Chemical Engineering by Felder and Ruscho. So let's move in. So in the first problem, let's see what is said. Water enters a 2-meter cube tank at a rate of 3 kg per second and is withdrawn at a rate of 3 kg per second. The tank is initially half full. Okay, let me think the process. Like if you have a tank, draw it. So let's suppose this is our tank and initially it is half filled. It is stated in the question. So let's say it is half filled with water. This is our water, and water is entering at a rate of 6 kg per second, and we are removing some water also. We are removing water at a rate of 3 kg per second. You can see here the input rate is higher than the output rate, so obviously some water gonna accumulate within the tank. We'll see that later. Now let's move to the part A of the question. Is this process continuous? Obviously the process is continuous because you can see there is input and output flow rate given. A process to be in continuous state, there must be an input flow rate and as well as an output flow rate. You can see the input flow rate is 6 kg per second and the output flow rate is 3 kg per second. That means the input and output flow rate is given. I mean, as water is continuously fed and removed from the tank, that means it's accumulating in it, so the process is continuous. And it is not necessary that the input and output flow rate to be equal to be in continuous state. I mean, in this particular example, the input flow rate is 6 kg per second, but the output flow rate is 3 kg per second. These are not equal, but it will be still in continuous state. Okay, so the process is continuous. Now the next part, uh, is it transient or steady state? The process actually is in transient state. Why it is in transient state? A process, to be in transient state, we have to check that if any process variable is changing or not. Process variable means temperature, pressure, or mass fraction. These are called the process variables. In this particular example, you can see the process variables are changing. I mean, look, the tank is our system. So as input flow rate is higher than the output flow rate, some water is gonna accumulate within the tank. As water is accumulating, that means the mass fraction of the water within the tank is increasing. As mass fraction is increasing, that means process variable is changing. So the process cannot be in steady state. The process must be in transient state as a process variable is changing. So it is in transient state. So what's the reason for that? The reason for that is the process variable change with time. Okay, so we are done with A. Now let's move to B. Write a mass balance for the process. Identify the terms of the general balance equation present in your equation and state the reason for omitting any terms. Okay, so we know that our general balance equation will be input minus output plus generation minus consumption equal to accumulation. Equal to accumulation. Sorry for the bad handwriting. Now we have to find out if anything is zero here. Now if you look at the example, no reaction is going to happen within the tank because it is just water, so there is no reaction. If there is no reaction going on, so the generation term and the consumption term will be zero because there is no reaction within the tank. So these two terms are zero. So we are left with input minus output equal to accumulation. So this is our final equation. I mean, that is what they asked. Write a mass balance for the process, identify the terms for general balance equation, present in your equation, state the reason for omitting any terms. Okay, we are done with our part B. So that will be our final equation. Why generation and consumption are zero? Because there is no reaction within the tank. Now moving to the part C of the question. How long will the tank take to overflow? I mean, you can see that the tank was initially half filled and you are inputting some water at, at a rate higher than the output rate. I mean, water entering at a higher rate than the removing rate. So obviously water is going to accumulate within the tank. So you have to find out how much time it is going to take to, let me choose another color, to overflow. That means the water will be filled, the tank will be filled with water. So this much volume of water will be needed to overflow. So we need we need to find out the mass of the water within this volume. The volume we can find easily because the volume of the tank is 2 meter cube, which is given in the equation. Look at there, the volume of the tank is 2 meter cube. So half of the volume is obviously 1 meter cube, 2 divided by 2. So this much volume is 1 meter cube. So we know the volume. The required volume is 1 meter cube. Now we need to find out the mass of the water. Why mass of the water? Because you are given mass flow rate, not the volume flow rate. So you have to find out the mass of the water, not the volume. So if you want to find out the mass of the water within this volume of the tank, you need to use an equation which is m equal to v multiplied by rho. Mass equal to volume into density. We can assume the density of water here is 100 kg per meter cube because temperature is not given anywhere in the question. So we can think that the rho is 100 kg per 1000 kg per meter cube. If nothing is stated, we can take rho as 100 kg 1000 kg per meter cube for water. So if you want to find out the mass of the water, it will be 1 meter cube multiplied by the density of the water, which is 1000 kg per meter cube. So meter cube gonna cancel out. You are left with 100 kg. Why am I saying 100? I don't know. It is 1000 kg. Sorry for the mistake. So the mass of the water in this half of the volume of the tank is 1000 kg. So you know the mass of the water. Now you can see per second 3 kg of water is accumulating within the tank. 6 kg is entering per second and 3 kg is removing per second. So that means 3 kg per second of water is accumulating within the tank. Pretty simple. Like you can see there, accumulation equal to input minus output. So input was 6 kg per second, output was 3 kg per second. You are left with 3 kg per second. That means 3 kg of water gonna accumulate within the tank per second. In 1 second 3 kg of water will be there. So we have to find in what second 100 kg of water will be there, right? So if you want to find out the time will be 100 kg divided by 3 kg per second. 3 kg per second. Now kg cancel out. 100 by 3 will be, let me put it on my calculator, 1000 by 3. Okay, the answer comes out to be this much amount of second. So 333.3 second will be required to overflow the tank. So that is our answer for part C. So we are done with our first question. We'll move to the second question now. Let me erase it.